All right, so the next form of a quadratic that we're going to look at is something called standard form. Now, most functions of graphs have something called a standard form. Okay, and basically all that standard form is it means that it's totally simplified. You'll notice that there's no like parentheses here. There's no order of operations that you can do. You can't combine any like terms or simplify this in any way, shape, or form. Okay, and it's written in order from the biggest exponent to the smallest exponent, aka no exponent, right? So that is what we call standard form. It is a thing that is always available for all these different types of graphs. Personally, I don't typically find them terribly useful. Okay, because where we looked at vertex form or transformation form and each part of the equation gave us useful information, that's not necessarily the case here. Okay, so when we look at standard form, the first thing that you're going to notice is this a value. That is the exact same a value that we saw in our transformation form and in our vertex form. Okay, so this a value still gives you your vertical shrink or stretch or flip. Okay, and actually all of the forms of quadratics that we're going to look at will have an a value in them and it will always be the same. Okay, so that part's the same so far. But the b number here, that doesn't give you any information. Okay, it's just a number and it doesn't really tell you anything directly about the shape or graph of your parabola. The c value does give you the y-intercept of your graph. Okay, so when we look at what our parabola looks like, just as a little example parabola, this point right here, that's your y-intercept, that is going to be the point 0, comma, whatever c is. Okay, it's a y-intercept, so you know the x-coordinate has to be 0, and then c tells you where on the y-axis it's going to go. Okay, so we do have that piece of information. Okay, and then what we can also pull out of here is we can find the vertex, but it's a little bit more work than usual. Okay, so our vertex, which we'll call the point h comma k, using the same letters we did last time, well, neither one of those letters shows up in this equation, which means we're going to have to find both. Okay, to find h, you have to do a little baby formula, and it's you do the opposite of whatever b is divided by 2 times a. Later on, next unit, we're going to talk about where this comes from. For right now, just trust me that this will work and this will get you the h or x coordinate of your vertex. Okay, so step 1 is you figure out what h is. Once you know what h is, you are then going to plug whatever that value is into the equation. So into the equation, okay, to find your k value. Okay, so you plug whatever, figure out basically what is x, and then plug that into your equation for x to figure out what your y value is. Okay, so this point down here, my vertex, that's still hk. All right, and then the other piece of information that we can get off of this is, of course, your axis of symmetry, right? Because once we know what these coordinates are, your axis of symmetry goes straight through your vertex, right? It's the equation x equals whatever h is. So your axis of symmetry, okay, is always x equals h, which in this case means it's x equals the opposite of b over 2a, because that's how we find h. Okay, great. All right, so let's look at this equation right here and we'll run through this. So first thing that I'm going to do is I can look at this and just identify what is my y-intercept. So this guy right here, that's my y-intercept. So that's going to be the point 0, 1. So the first thing I'm going to do is put a point at 0, 1. That's my y-intercept. Not the vertex, just the y-intercept. Okay, now we're going to calculate the vertex. And in order to do that, I'm going to start with h equals the opposite of b over 2a. So this guy's b, it's a negative 6. So the opposite of negative 6 is positive 6 over 2 times my a value, which is 3. So that's 6 over 6, which is 1. Okay, then I'm going to take that 1, I'm going to plug it back into this equation for x. So I'm going to do 3 times 1 squared minus 6 times 1 plus 1. And I'm taking this number and I'm plugging it in for x in both spots. Make sure you follow order of operations when you simplify. Don't multiply the 3 and the 1 and then square it. That's not how this goes. Square first, then multiply. So 1 squared is 1, times 3 is 3. 6 times 1 is 6. Okay, and then if we combine all that together, 3 minus 6 plus 1 is -2. So this tells me that my vertex is the point 1, -2. Okay, so my vertex is 1, -2. There's that guy. Oops, that's in the wrong spot. Sorry. I was confused for a second because I was like, wait a minute, that doesn't look right. Yeah, there we go. 1, -2. Sorry, I plotted it in the wrong spot. Okay. Now, that also gives us our axis of symmetry, right? So when we go to plot some more points, we can't just leave it with 2 points, right? So here's what I can do, though, is I know this is my axis of symmetry, which means that if this point is 1 space away from that axis, there has to be another point equally distant on the other side. So I know I'm going to have another point there. And I've got that this number right here, that is my vertical stretch by a factor of 3, right? So if we check this, normally we'd think, well, go over 1, up 1. I'm going 3 times as far, so I'd go over 1 and up 3. Well, that's at that same point, right? Over 1, up 3. So we know we're on the right track. My next one, instead of over 2 and up 4, I would go over 2 and up 12, because I'm multiplying it by 3. So over 2 and up 2, 8, 12. So that's about there. And then I can reflect that over. And that's what my graph's going to look like. Okay, so we're still using this vertical shrink stretch thing to figure out where my points are going to go. All right, let's do another example. So this guy right here. So the first thing that I have is my y-intercept. Okay, and my y-intercept is actually still 0, 1. It happens to be the same. So 0, 1, there's my y-intercept. I'm going to plot that on there. Next, I'm going to find my vertex. So it's h equals the opposite of b. B is -8, so it's going to be +8, over 2 times a. Well, a is -2. So that's 8 over -4, which is -2. Okay, and then to figure out k, I'm going to plug that back in for x. So it's going to be -2 times -2 squared minus 8 times -2 plus 1. Plugging this number in there. All right, again, order of operations, square first, then multiply by the -2. -2 squared is +4, so times -2 is -8. -8 times -2 is +16 plus 1. Okay, and that simplifies to 9. So my vertex is going to be the point -2, 9. So -2, 9, that's up here. Okay. So then from there, I know my axis of symmetry runs through my vertex. Almost put it in the wrong spot there, but there we go, through the vertex, which means if this point is 2 spaces away horizontally from the axis of symmetry, there's another point 2 spaces away in the same direction. Okay, and then I can use this guy right here. So remember, this is telling me 2 different things. This is telling me, because it's negative, that there's a vertical flip. And because it's a 2, there's a vertical stretch. Okay, so when I'm going to plot these points from my vertex, normally I'd go over 1, up 1. Well, now I'm essentially multiplying it by -2. I'm going to go down, and I'm going to go twice as far. So instead of going over 1, up 1, I'm going to go over 1 and down 2. Then my next point, I'd go over 2 and up 4 usually. Well, I'm going to go over 2 and down 8. So over 2, down 8. That's where that guy came from. Next, I would go over 3 and up 9. Well, that's going to be over 3 and down 18. That's not going to fit on here, so I'm not going to put it on. But I am going to give a general idea of where this guy goes. Oh, I forgot to reflect this one over. There we go. Now he's reflected over as well. Okay, and there's my graph in standard form. So standard form, I think, is a little bit trickier than vertex form or transformation form, just because you have to remember that little formula. And I feel like it's a little bit more work, but it's not too bad. All right, and then last thing, rewriting equations into vertex form. So I have an equation here in standard form, and you need to be able to write this in vertex form. Okay, so how are we going to do that? Well, basically what we're going to do is we're going to use these same steps to calculate your vertex. And then we know, we said before, that this A value is going to stay the same. So you'll have your A value and you'll have your vertex, and you can just pop that in. Okay? So I'm going to start by finding my vertex. So it's H equals the opposite of B. B is positive 4, so it's going to be negative 4. Over 2 times A, which is, there's an invisible 1 there, right? Okay, so negative 4 divided by 2 is negative 2. Plugging that back in, I'm going to get negative 2 squared plus 4 times negative 2 plus 3. So negative 2 squared, positive 4. 4 times negative 2, negative 8, plus 3. So that's going to be negative 1, right? Okay, so then I have my vertex here. So my vertex is negative 2, negative 1. All right, and then I know that my A value is going to stay the same, so that 1 is going to be the same A value. And that's all the information that I need. I can then write this into vertex form. So it's going to be y equals A, which is 1. I'm going to write it in for now, but you obviously don't have to write the 1 in. Parentheses x minus the h value, x minus negative 2. So minus negative 2 is going to become a plus, right? Squared. And then plus k. Plus negative 1, same thing as minus 1. So there is my equation written out in vertex form. Okay, so really quick, just running back over these last ones. So this guy, if I wanted to put him in vertex form, right, it would be y equals the A value, which is negative 2, and then parentheses x minus h, so minus negative 2, again, that's going to become a plus 2 squared, and then plus k, so plus 9. So that's my equation in vertex form. This guy up here, same thing. So it would be y equals my A value, which is 3, parentheses x minus h, which is 1, squared, and then plus k, so plus negative 2 minus 2. There's that equation in vertex form. Okay, so putting it in vertex form, not awful. It's basically the same steps. You just don't graph it. You just write the equation. Okay, so that is how standard form works. Make sure that you memorize this equation. You need to know this opposite of b over 2a, and you need to be able to remember that really quickly and easily. Okay, but if you can remember that, the rest of it's really not too bad.